Okay, so the second one here, I'm just going to draw the way that the little one at the bottom seems to be drawn. So it kind of looks like this. And then a smaller one, it looks like this. What did I say was kind of the key as you're labeling these guys? Here's the smaller one. We'll just go ahead and label it. As far as making sure that you've got it turned correctly and you're writing down the correct lengths. What are you going to be looking for? This is what length on this triangle compared to the other lengths?
The shortest.
It's the shortest one, right? So that's kind of, I would look for the shortest and the longest and then make sure your triangle's oriented so that you've got the shortest one for this one here and the longest one for this one here, right? And so we can look at the numbers and see very clearly that the shortest is 12, the longest is 28, and the medium length one is 24. So that'll make sure that you've got it, you've drawn your numbers on there and oriented your triangle correctly. And so then it's very easy to check things like the proportions of the sides, the ratio of the lengths of the sides. How are we going to tackle this one to figure out whether or not it's similar? Do we know anything about angles? We don't. We have no idea what these angles are. Even if you look at it and you go, well, it looks like this angle might be 90 degrees, you can't assume that, right? So we know nothing about the angle, so we really only have one choice here for proving similarity, and it's what?
Side, side, side.
Side, side, side. That's the only option we have, right? So that means that the ratio of the lengths have to be the same for each of them. So if we take the length of each side, just kind of going around, we can start either way. We could write it 12 over 3, right? This number first and over this number, or we could write it in the reverse direction. We could say 3 over 12. It doesn't matter as long as you start with the same triangle as you're defining your numerator and your denominator. So we'll just say 12 over 3 has to be the same as 28 over 7, has to be the same as 24 over 6. All of those have to be the same ratio. And if we look at this, that means all of them have to equal 4 if we write them like that. Largest number over smallest, right? Do they? They do, right? So we can say based on that, then similar by side, side, side. Now, I told you that I wanted you to write a similarity statement. So I give you the beginning of the similarity statement. I say triangle ABC, and let me label ABC. The way that I've drawn it here, this is A. 12 and 24, value between those is B, and so this is C. And so again, this is where, redrawing it will make it very simple as far as writing your similarity statement correctly, because your vertices have to match up, right? Wherever vertex A is in this triangle, that has to match vertex T in this triangle, okay? So I have to say triangle ABC is equal to triangle TB corresponds to vertex V, T, or is that a U? That's actually a U, sorry. Poorly drawn U. T, U, B. So that would be the correct way to write that similarity statement. What's that?
You said TUV, so I said WXY.
WXYZ, yeah. And I wish you could hear my grandson say W. It's like he does great on all of the letters, but W is like, I don't know. I can't even duplicate what it is that he says when he gets to W. But hey, he's 2, so he can say his entire alphabet. That's pretty cool. And we're not even sure how he learned it. His mom was like, I didn't really sit down and teach him that. I think he watches Coco Melon. If you guys have any younger siblings and you're familiar with that, so maybe he picked it up from Coco Melon. Anyway, one day he'll just like be looking over my shoulder and he'll tell me how geometry works. Number 3. Where'd you learn that? I don't know. We watch this Coco Melon.
Melon taught me geometry.
So everybody clear? Got that? Let's do another one. So these here can be a little confusing, and so I think it's important that you understand how these are laid out, how to draw the triangles properly oriented with one another. So this is U, T, L, M, in. And this is all the problem gives you. Man, that's not a lot, right? That is not a lot. But is it enough? It is enough. So, the reason this one's enough, now do we know anything, for this one, do we know anything about the sides?
Nope.
We know nothing about the length of the sides. We know these two sides here are parallel, right? But as far as the length goes, we don't know anything about the sides. So all of the theorems that have side in it, right? Like side, 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 or side, angle, side, they're out. We have to use a theorem that's only got angles in it, which we've got one option for that, right? What is it?
Angle, angle.
Angle, angle, right? So we're going to have to try to use angle, angle. So can we prove that two angles are the same in this one based on the information that we have? And Camille is just like, her head is shaking so hard, I'm afraid it's going to fall off. So she says definitely yes. Which two angles are the same?
Okay, so the ones where they're like intersecting, those
Yep.
are vertical angles,
Right.
so those are going to be the same.
Okay, good. So if we were doing a proof, like she said, we would say those angles have to be congruent because of
The vertical,
vertical
angle
angles
theorem.
theorem, right? Excellent.
And then angle M is congruent to angle U
Angle M is congruent to angle U. How do you know that?
because
Remember the name of that postulate or theorem? I can't remember if it's a postulate or a theorem, but or maybe it's be a definition.
I forgot what.
Yeah.
Alternate.
What are these called?
Oh,
Does anybody know what kind of angles these are? This was where we had a scenario where we had two parallel lines and a transversal that crossed that parallel line.
the alternate
And we knew these angles here were the same.
consecutive angle.
Or I'm sorry, these angles, not those. I did it wrong, right? These angles are,
Wait,
wait a minute, it's these angles, sorry, 2 and 2. These angles are the same, right? So what'd you say?
Consecutive interior or
alternate
interior.
Alternate interior angles are the same, right? So that's why these two are identical. And we could have used the same logic to say this as well, but we didn't need to. We've got two now, so we've got enough, right? So we've proven that those two are the same. Again, you don't have to write down anything about alternate interior angles and anything about vertical angles. It's just if you get it wrong and you gave me some additional information like that, then I could give you some partial credit for at least knowing that piece, right? But these are similar by Alcoholics Anonymous. This is what I think of every time I see AA.
yeah, that's a
These are similar
They're
by
singing a song about
AA and LMN. I don't think they thought about that when they determined the name of Alcoholics
Yeah.
Anonymous. It's like, that's also a theorem in geometry. No one was thinking that. So what would my triangle be? So this is where it maybe gets a little bit confusing. But if you'll just kind of making a note on my key here that I didn't do something. Triangle, a little triangle symbol's missing. Here's the way to think about this. We know that if we were to draw these guys, that this point has to be the same, right? So L will be the same on both of these. So if I'm saying triangle LMN is similar to the other triangle, I know that L is going to be my first one because L is the same point on both of those guys, right? Has to be the same vertex. But the question is, which side does this correspond to on this triangle?
M.
Well, the side.
Oh.
So side, line segment UL corresponds to what line segment? LM. So that's how you have to think about it. It's like when we're showing this, when we think about these as being similar, you've got to take this triangle here and flip it this way and then flip it up like that, right? And that's how the similarity works. So these sides are the similar ones, and then these sides are similar, and of course these sides here are similar as well. So that being said, L. If this goes from L to M, then this one has to go from L to U, right? And then the last one's easy. It's just the only other vertex left. Okay? So these that do that crisscross with vertical angles, they will always work out like that. This side will correspond to this side, and this side will correspond to this side. This side will correspond to that side. Okay? Does anybody need me to actually write down the two triangles, or you guys got that? Got it? Think about it in your mind. Is it going boom, boom, and that's how they line up. Okay? And then we have one more. Any questions about that last one? Notice I'm not looking, so I won't know. And that way I don't have to, I just pretend there's no questions. Any questions? No? Nobody has any questions? Okay, good. No, seriously, does anyone have any questions? No? All right. So let's do the last one. At least for these types. It looks like this. L, M, G, E, F, 63, 36, 4, and 7. If it is similar, we need to show how it's similar to triangle GFE. Do we know anything about the sides?
Yes.
Yes,
Yes.
we have some length of sides, so that means all of the theorems that involve sides, they're on the table. What about angles? Do we know anything about angles?
Yes.
We
Yes.
do, right? So we know that these two, because they're vertical angles, that these two angles are congruent to one another, right? And since you were shaking your head again so violently, well, okay, it wasn't really violent, but it was smilingly. It was very smilingly shaking of your head. Well, I'll put Annalie on there. We know, so we know something about the sides and we know something about angle. Do we know anything about any of the other angles? Like, is angle an option here?
It would work.
Would it?
Or
Yes, Aiden.
It's not shown that the sides are parallel, so we cannot assume.
Because we didn't have these sides listed as parallel, the whole thing with two parallel lines and a transversal, that doesn't matter here because we don't know that those lines are actually parallel. They look like they are, but we don't know that they are. Okay? So we can't assume that. So really our only option here, do we know anything about this third side? We don't know anything about it. So side is not an option. So we're locked into side, angle, side. That's the only choice that we have, right? So we've got to prove that the ratio of this, of these guys, of this triangle and this triangle are going to be the same. Now, this is where it gets tricky if you don't see how these triangles flip and are similar to one another. 4 over what has to be equal to 7 over what? Cal.
4 over 36.
Wait a minute. 4 over 36. 4 over this? Are you serious? Is he right, Cameron?
Yes.
Oh, he is. Okay. So 4 over 36 has to be equal to 7 over 63. The only one that's right. So he's exactly right. That's right. So again, you have to realize it's really tricky when it's drawn like this, right? It just seems like, oh, that just flips down and they're similar, right? So this side corresponds to that side. No, this side, it flips down and then it goes, how am I going to do that? It goes down and then it goes like that. If I could break my wrist, then you would see how that works, right? This side here will correspond to this side, and this side will correspond to that side. So you got to get the numbers right. This is a problem that students make all the time, right? They say 4 goes with 63 and 7 goes with 36, and that doesn't work. Yes, Aiden.
The way I was originally taught it was that it's kind of like a rectangle that's been twisted.
Oh,
so
yeah.
When you untwist it, it's
That's
lined up.
I can see that. Yeah, that's a good way to think about it.
Like your wrist.
Yeah. Huh?
Like your wrist.
Like yeah, exactly. It was twisted. Okay. So we just have to verify that this ratio is the same for both of these guys. 4 will go into 36 9 times, and 7 will go to 63 9 times. So they both reduce down to 1 over 9. So we can prove similar by SAS, right? Now, let me ask you a question. What if this had been drawn like this? Are they similar? Can we prove they're similar? You say we can? Do we have a side-side angle or an angle side-side theorem? We don't. Right? So if I don't have two sides with an angle between it, I can't use side angle side, right? The angle has to be between the two sides that we know are proportional to one another. Okay, so that's an important distinction there. This is not the same as what we had before, all right? But that's not what we had. We had this, so that is valid. Okay? So what's our triangle? GFE corresponds to G is the same. What corresponds to F?
L.
L, that's right. So then the only thing left is M. This point corresponds to that one. This point corresponds to that one. Okay, any questions about proving triangles are similar? You guys got that down? I hope that if you didn't get it correct the first time you took the quiz, that you've written down the correct answer now, so that you will use that for studying. All right, let's. The last two problems had to do with like the last two pieces that we learned. I think it was at the very end of 8.6, and we had these three lines that we're told are parallel. We know they're parallel because they all have these arrows in the middle. And so we have this one line that goes like this. And we've got another line that goes, I'll make these a little longer, another line that goes like this. And we're told that this length is 10. We're told that this length here is 18. And this, we don't know what that is, and we know what that is. All right? So we have a theorem. Is it a theorem or a postulate? And where are my notes? This is not good. I don't see them. You can tell it's bad when it starts dropping stuff. What do I do with them? Pull them out. Oh, they're in the books. Okay, good. All right. So in section 8.6, you know, something that you will write down on your note card for the test is, it's theorem 8.6 that this is relevant to. All right? This is supposed to be nice straight lines. I didn't do a very good job of that. Just ignore that. What does that theorem tell us? Can we figure this out? Can we? Yes. I'm going to make this an X just so we'll have a variable there. Ian?
Be so the 18 minus 10 is 8,
So that means that's the length of that side, right?
so it'd be 10 over 8 is equal to x over 12.
10 over 8 equals X over 12. That's correct. Now the important thing here is that if I'm going to say 10 over 8, I have to make sure on this end that I start with this, with the section that's in between these two parallel lines, right? I had 10 in my numerator here, so I got to make sure my X is my numerator in my numerator here. Again, that's one of the areas that students make mistakes. They say 10 over 8 and then they say 12 over X. You can't do that. You have to use the side, the line segment that corresponds. The line segments have to, if this line segment is on the top here, then this line segment has to be on the top here, okay? There's actually two ways that you can think about it that will work as long as you keep those same paths. You could also say that 10 over X is equal to 8 over 12. You could say it like that as well. And again, see, I made sure that this was on the top of my numerator here, and so then I made sure this was on top of my numerator here. So both of those will give you the same answer, because if you notice, if you cross multiply, you get exactly the same thing. Either of those would work. I can't remember which way the theorem was actually. The theorem actually does it UW over WY. So the theorem did it like you did it, Ian, right? 10 over 8, X over 12. Which is fine. But I just want you to see, if you mix that up, if you try to do this over this, that's still fine as well, as long as you start with do this over this for the other one, and you'll still get the same answer. Okay? So if we solve this guy, what are we going to use to solve it? Ian, we're going to do what?
Cross multiply.
Cross multiply, so we get 8x equals 10, 120. And then that equals
15.
15, yeah. X equals 15. Any questions about that? That's just taking that theorem and plugging it in. But does anybody want me to walk them through that again? Now don't get confused about the fact that I could draw these parallel lines all sorts of crazy ways on the test, right? And this one looks odd, looks like that, right? Could be more this kind of look here, and maybe we've got a line that does like this and another line that does like this. I mean, there's all kinds of ways that I could have drawn it, but it's the ratio between these lengths, right, that are important. And so if I were to draw it like that, who could give me an equation that correlates A, B, C, and D all together? Let's take a stab at that. Aiden?
Just A over B equals C over D.
A over B equals C over D, right? You put A in the numerator here, and so as we move across our parallel lines, that means I got to put C in the numerator on the other side, right? So as long as you do that, you'll be good. Okay, the last problem was this one. Looks like this, and this guy looks like this. And this looks a little different than the theorem, than the definition in the book for the theorem that this corresponds to, theorem 8.7. Because theorem 8.7 is about a ray bisecting the angle of a triangle. So why is this one though, why is that the theorem we're going to use to solve this problem? How do we know to use that theorem? There's a little more to the problem, of course. We've got a 6, and we've got a question mark here, and we've got a 10 and a 15. But how do I know theorem 8.7 is going to be what saves me here? Joshua.
Can't you tell a line's a bisector where the two lines that indicate the angle?
Very good, exactly. So that theorem is about a ray bisecting an angle, and we know that this line segment here bisects this angle because the angles on each side of it are the same. They're congruent, right? So that's how we know that that's the relevant theorem for solving this problem. So who can give me the equation that would relate all these numbers to one another? Cameron.
10 over...
I'll put an X right here.
Okay. 10 over x equals 15 over 6.
10 over X equals 15 over 6. Exactly. So again, same kind of thing that we had here. As long as we started with the numerator in this little triangle. So our numerator for the other side also has to come from this little triangle, right? And the denominator for the first side comes from this little triangle. I'm saying little just because it's smaller than the bigger one here. So the denominator on this side also has to come from this little triangle. So if you set it up like that, then you'll get 60 equals 5x, or x equals, what is that?
4.
12, huh? 4?
4.
Did I do it wrong?
No,
Oh, 15.
15x.
I was like, what? I'm getting 12 here. Okay, yeah, 4. X equals 4.
I didn't see what you didn't do.
Now again, same as what we did before. I could have said x to 6. I could have done it like that. X to 6 equals, and again, as long as I stick with the same, this same side here, I could have said 10 over 15. Right? This is the smaller side in this triangle. This is the smaller side in that triangle. So x is to 6 as 10 is to 15. And if we cross multiply here, we get the exact same thing. Right? X equals 4. So that'll work as well. But the order is really important. Just make sure whatever you start with in your numerator, that it makes sense that you would start with that one in the numerator of the other side of the equation. Any questions about any of these problems from this quiz? No? Well, let me hand out this huge packet here. It's going to take you guys like 8 hours to do.
Yay.
How many problems?
1,030? No, it's only,
5.
it's
1.
With 27 parts.
Yes.
It's 32 plus, wait, I'm not done.
32 pages?
32 plus 22.
Okay.
So 54?
It's not hard.
Questions? It's not too bad.
54. It's not horrible, and
It's
actually,
like the average for.
The other one had 100.
oh, did it? Okay, so yeah, this is a piece of cake, right?
Wait,
So
Is there
actually, huh?
Is there proof?
There are proofs on these, and so the proofs are. I haven't decided what I'm going to do as far as the proof goes, but this will give you some practice for proofs. All right. You know what? I'm just going to hand these to you guys. Take 4 pages and pass it down. All right.
Oh, I thought it was stapled together because I have this
I
thing
know,
right
that's
here.
what I thought.
So the numbers are not going to be sequential. There's like the beginning of one packet. I took the first 22 problems from one packet, and then the numbers start over again, and you'll have 1 through 32, I think, on the second.
Gotcha.
So the first 2 pages come from. The first page front and back comes from one review, and then the last 3 pages front and back are the second review. Okay. So let's
I would be so happy if I actually had it on
For 2 years.
Oh yeah.
the. I'm gonna try and get it on the staple. I hope so.
get all this passed around.
How close I was.
Oh,
Things I get excited about.
Now, so of course
Uh-huh.
your last quizzes are a good study tool for this test, which I'll hand out next week, Lord willing. Should have said that last week because I didn't hand it out this week.
So where's
And then this study guide will be a good resource for studying for the test. Just like before, you can have a note card. I'll do front and back again for the note card for this section. And so you can write all your theorems and postulates down and so forth. It's not a bad idea maybe to, if you want to take up a little room, especially if there's a proof. And I'm not sure if there's going to be a proof. If there is a proof, it'll be kind of it'll be like I've done before, where there's sort of a skeleton there, and I've got some of the lines filled in, and you'll just have to fill in the pieces that are missing, right? So it'll be set up like that. It won't be nearly as complicated. What was that one we tried to do this morning, Joey? What number was that? I don't remember. We tried to tackle one, and it was like 9 steps, and
Oh yeah.
yeah, it was not an easy one. So I'm not going to give you anything super hard. But I just wanted to make sure you remember things like the vertical angles. You know, some of the theorems from the past ones are like vertical angles and corresponding angles, and you know that type of stuff like we did when we were proving similarity. You have to know that to prove similarity anyway, so it should be easy to remember that for your proofs as well. But let's just pick a few of these out, and what I'll plan to do is I'll upload to Google Classroom whenever I put your assignment on there, which is just simply going to be complete this review to study for the test and write your get your note card together. I will also post the solutions, so you'll have that to go by, right, as you're doing your review, your study guide. So let's just look at a few of these. Just kind of randomly pick some and make sure that you know how to do them. So we're just writing a ratio in its simplest form in these first 6 problems. These problems are kind of repetitive, so if a lot of times if you can do a couple of them, you can do the rest. And I always hesitate to say this, but if you do a couple of them and you're totally confident that you know the rest, and I'm not concerned about you doing the rest, right? But let me just say, if you're not acing all the tests, do all the problems, all right? Go ahead and say, I might think I know the rest of these, but I'm going to do them anyway just to make sure that I know the rest of these, okay? The more problems you do, the better you're going to get at it. 28, so we're going to write a ratio in its simplest form, and it says 28 elementary schools, the ratio of 28 elementary schools to 16 middle schools. What would that ratio be?
7 to 4.
7 over 4. I don't see a 7 or a 4 in 28 and 16. So
If you divide them by 4.
what?
If you divide them by 4,
So you're telling me that I would do 28 divided by 16, and then I would divide top and bottom by 4, and that would give me 7 over 4? Right?
yeah.
That's right. David's right. So you just take the first number and you put it over the second number, right? And that would be the ratio of the two. And so all of these work exactly the same way. You just take the first number over the second number. Let's see, let's do something that's a little more interesting. Well, so pay attention to the description of the problem. One of the things that I saw in the last test that you guys took was some of you guys, I would give you a problem that had a variable in it. And so you would get the correct answer for the variable. You would say, for example, something like x equals 4, which is absolutely correct. But the problem said, tell me what the measure of angle G is, right? So you were supposed to take the x value and plug it back into the formula that corresponded to angle G, and then you would give me the measure of angle G. So you missed like all these points here and there because of just not reading the directions completely. Some of you guys I saved because I told you I didn't have all of the theorems with me when I was on vacation, and so I didn't remember what the numbers were in the book, and so I just gave everybody credit for those problems when it said give the answer and the theorem that you used to find the answer. I just gave you credit for the theorems, but some of you guys didn't even bother to put the theorem down, right? So if I hadn't just kind of given you that as a freebie, you'd have been in trouble. You'd have missed points here and there for not listing the theorem. So make sure you've got everything that the problem asked for. Several of you, when we had a figure that was like something like this, and it said give the most specific name, maybe give the name of the figure, the most specific name of the figure, state whether it's convex and concave, and if it's regular or not regular. And some of you guys would give me 2 pieces of that information and would just totally ignore the third one. So I don't know if you didn't know, or I suspect you just missed that in the instructions. So pay careful attention to the instructions, okay? So number 5, for example, the hockey team played 82 regular season games last year. They won 44 games. What is the ratio of wins to losses? So if you just look at this problem and go, it's the same problem that we had before, 82 over 44, and you start simplifying and you're like, I'm done. Well, you're not done because that's not what the problem asked for. It didn't ask you for the number of regular season games compared to the number of games they won. It's the number of wins to losses. So you'd have to say 82 minus 44 equals 38, right? And so then wins to losses would be 44 over 38, which it's asking you for the simplest form. So this answer is not correct, right? You have to simplify that fraction in order to get the correct answer. So the correct answer here would be 22 over 19. So make sure you've read all of the directions and understand what I'm asking for. Okay? Any questions about these simple ratio problems? It's been a great day for someone to bless me with a coffee.
Is he gonna bring it from computer science?
Huh?
Is he gonna bring it
Computer
from
science. There's this headache that's been starting in the back of this eye, and it's just still there. I don't know if a coffee would have fixed it, but it might have helped. It would have made me feel like things are better. Let's look at the next section here where it says, use the given ratios to solve each problem. So this is very similar. Here the ratios are listed not in the form that we did them up top where it's in fractional form, but it's listed using the colons, right? So we have a ratio in number 7 of 7 to 8, right? Now if I ever ask you for a ratio, if you give it to me like this or if you give it to me like this, I'm going to give you credit for that. You could write it in fractional form or using that colon notation there. But the ratio of the measure of 2 complementary angles is 7 to 8. What is the measure of the smaller angle? Who can set up an equation for me that would make it possible for me to find the measure of the smaller angle? Anybody want to take a stab at that? Do you know how to do that? I don't know that we've worked a problem exactly like this on the board. Ian?
7 over 15 equals x over, complementary is 90, right?
Complementary is 90. That's
Over
right.
90.
So you said 7 over 15 is equal to what?
X over 90.
7 over 15 is equal to x over 90. I don't think that will quite, I'm trying to think through your logic there, but I don't think that will give you the correct answer. That's a good try though. Where'd you get the 15 from?
7 plus 8.
7 plus 8, right? You got that from there. You're on the right track with those added together, but here's the, I think the easiest way to figure this one out. We've got some angle that's related to another angle where the ratio is 7 and 8, okay? So we don't sort of know this unknown base term here. We could say that the angles were just 7 plus 8, but we know they're bigger than that because they have to add up to 90, right? So both of these guys are multiplied by some constant, and the total amount of degrees is 90. Does that make sense why I would write it down like that?
Why would the other one not work?
Well, so you said, when I was doing the math in my head, I thought you said 7 over 15 equals x over 90.
Yeah, that is.
Is that right?
Mm.
And so you see what we're going to get here is we're going to get 15x equals 90. This is going to give us 15x equals 7 times 90. So we're going to get a much larger value for this one,
Okay.
right?
Yeah.
Yes, Mary.
Just wondering why that would be.
I worked 7 over 15 equals x over 90 out, and it still gives you the right answer.
This still gives you the right answer?
Because it would be 15x equals 630, and 630 divided by 15 is 42. And then if you did the same thing with the 8, it would give you 48, and that equals 90.
Oh, I got you. This gives you immediately the correct angle. Yeah, versus this one here where you've got to take the x and you've got to plug it back in with what you define the angle as. Okay, yeah. I got you. So either one would work. Well, I'm gonna put a +2 next to Ian.
Yes.
And then I'll put Mary's name on board for rescuing Ian in that one, right? I was just looking at it going, wait a minute, our x's are totally different. There's no way that can work. But this just takes you directly to the 42-degree angle, which is what the final answer is. So this is actually kind of quicker. This one here, right, if you did this, x is equal to 6, right? But we asked what was the smaller angle, and we've defined the smaller angle in this one as 7. So 7 times 6 is going to equal 42 degrees. So that's our smaller angle. So nice job. What I don't have in my mind is a good way to explain that. Can you guys explain why that works? Other than you
just take the sum, put it in the denominator, and just take the smaller angle and make it the numerator.
I mean, I see that it works because of what we just did. To try to explain that to the class, I understand this trick works, but I'm not sure how to explain that. Yes?
Kind of, but I don't know if I can. Okay, so 7 was that part out of. Never mind. I'm not gonna be able to get it out.
That 7 was that part of 15, maybe
right.
the total.
And then
right?
x was we needed a certain part out of 90.
Yeah.
That
Okay, that works.
kind of
So that's a good
relates
way
to
to
it.
think about it. Yeah. So 7 is how much of 15, which is the total amount of the angles. If the angles were just 7 and 8, 7's that part of the total amount of those two angles. And we're using 7 here because we were interested in the smaller angle. That's why we picked 7, right? If I asked you for the larger of the two angles, we'd have had to do 8 over 15, right? But we do 7 as part of the 15, which is the total of the two, just as x is part of 90, which would be the total of the two actual angles that are in the triangle. So there you go. All right, good. Thank you. So you saved me there, so I'm going to put a +2 next to your name also. Good job. All All right, any questions though? Either way that makes sense in your mind is sufficient for working this. All right. Do I need to walk through that again with anybody? And depending on how complicated the problem gets, one way may end up proving itself to be easier than the other. Well, take like, for example, the next one. The next one, the ratio of the measure of three angles in a triangle is 2, 9, 4, right? And we're trying to find the measure of all the angles. So for this one here, I think it would be simpler to just say that means that 2x plus 9x plus 4x equals, not 360, we're in a triangle, so equals 180, right? So all of those added together has got to equal 180. And so then when we do the math for that, we've got 15x equals 180, and so x is equal to 12. So the problem, again, we have to see what the problem asks us for. The problem asks us for the measure of each angle. So that means then the first angle is 2x, or 2 times 12, which is 24 degrees. The second angle is 9x, or 9 times 12, which is 108 degrees. And then 4x is 4 times 12, which is 48 degrees. So those would be our three angles. And we could double check that and make sure that they all added up to 180, which they do. But this mechanism here works really well for when you've got three, when you're trying to find three. Is there a quick way to do it that you guys know of when you're doing three like that? No?
I just did it the same way, but it takes longer.
You did it the same way. You did the two together, right? And figured out each of these individually, and then, yeah, so that might be a little bit longer. So you could do that. You could say, well, I know there's a ratio of 2 to 9 for 1. Well, but how do you know this value?
It's 180, and I added 2, 9, 4 together to get 15 again.
Okay, I got you. So you added 2, 9, 4. Oh, so you did each one. I see what you're saying.
Yeah.
I see what you're saying. Okay, so she had to do three different problems basically to come up with these shapes, which we kind of did here, but these we could kind of do in our head once we found the x. Yeah. All right. Questions? Nudge your neighbor if they look like they're nodding off. Trying to help you guys do well on this test. I don't see anybody nodding off, but some of you guys I think are able to sleep with your eyes open. So hear some snoring. All right, anything else on that first page that you're looking at going, I don't know how to do this one? Those look like they're all pretty similar. We've got some where they're asking for the perimeter, right? And they give us the perimeter that it all adds up to. So we would set up the same type of equation. Like number 12 says the ratio of the measure of the sides of a triangle are 475. The perimeter of the triangle is 128 yards. Find the length of the longest side. So we would say, since it's 475, we would say 4x plus 7x plus 5x equals the perimeter that they gave us, 128. And then solving for x, that would give us 8. X equals 8. And so they asked us for the length of the longest side, which corresponds to the 7x here. So we would say 7 times 8 equals 56 yards. 56 yards would be the answer for that one. But you set it up very similarly. You do have to know terms like, well, what are some of the things you need to know for these problems? You need to know that corresponding means the angles equal 90 degrees, right? If I'd given you a problem where I said use supplementary, you would say they equal. You could hear a pin drop. It was so quiet when I said that.
180.
180, right? We had one problem where it was all the angles in a triangle, which we know equal 180. What if I'd given you all the angles in a quadrilateral?
360.
360, right? So there's all kinds of ways we could have approached this problem using perimeters and so forth. The problems on the back are just kind of straight. I'm not even going to go through those problems. I'll do one, okay, just to make sure we've got it. On the back of that first page there, and let's do. the one that's got, the hardest ones are those last two at the bottom there, right? So for those two, we've got x minus 9 over 3 equals 56 over x plus 4. Right? And so what do we do to find the answer? When we've got two fractions equal to one another, we always cross multiply, right? So cross multiply is the answer there, and we come up with x minus 9 times x plus 4 equals 3 times 56, which is 168. And so for this one here, we actually get a quadratic equation, right? We have to use the FOIL method to get x squared equals negative 9x plus 4x, so negative 5x minus 36 equals 168. Then we move the 168 over to this side, and you get x squared minus 5x minus 204 equals 0. That looks like great fun. So you're just trying to find factors of 204 where the difference are.
Wait, Kevin.
Where did you get the negative 5x?
Negative 9x and positive 4x.
Oh,
Just when I did the FOIL method,
Oh, you
so
just
first is
put
x
it-
squared,
okay.
outer is 4x, inner is negative 9x, so 4 minus
Oh,
9x,
so you just
4x minus
combined
9x. Yeah, I'm sorry. I went ahead and put them together, negative 5x. Anybody super uncomfortable with doing that? Did you guys get that? Was that fully indoctrinated into you whenever you took Algebra 1? Yes? Okay. What about factoring these suckers? What about going the other direction? This is really harder than a problem I'm going to give you on a test, but maybe I would be mean enough to give you a simpler version of that. I don't think I would expect you to know what the factors of 204 are. But you can figure it out. You're smart enough to do that, right? So if you figured it out, you would say x, one of them's got to be minus, one of them's got to be positive. So you're looking for the factors of 204 where the difference gives you a 5, specifically a negative 5. So it turns out that we're going to have a minus 17 and we're going to have a positive 12. 17 times 12 is 204. And the difference of negative 17 and 12 is a negative 5, so that matches this. So there's two possibilities for x for this one. X can equal 17 or x can equal negative 12. So for some of you, that's going to be a blast from the past, right? Maybe you haven't done that in a while. I don't know if we've done that in here. We've done any quadratic equations, factoring quadratics in here at all? Yeah. If I put one of these on the test, it'll be accidental. Right? I won't intentionally do that. I would want you to be able to figure out problems like number 18, where it's x minus 16 over x plus 6 equals 3/5. You're doing exactly the same thing. It's just when you cross multiply with this one, you don't get a quadratic, right? But I will say this. One of the things Miss Hersey said is that there's a problem when you guys take geometry that kids tend to forget some of the algebra stuff because we don't use it much in geometry, and then they come back to algebra 2 and they're like, it's been a year, right, and 3 months or whatever since I've looked at this, and I have no idea. So this is an important concept. Don't let this fall from your mind, because it doesn't go away. It sticks around for a long, long time in your mathematical career. All right. Questions about solving these problems? Just cross multiply and solve for x, right? Everybody clear on that? All right.
Yes, sir.
By the way, I am going to spot check this next week for your homework assignment, so make sure that you do it, okay? I'm not going to do problems 1 and 2 on the next page because those are the same type of problems we've already done. I really just wanted to give you more practice on those. That's why I included the other worksheet. What about the scale factor? Number 3. The scale factor of similar figures. Is that something's done, it's ready to take out of the oven. You guys hear that?
Yeah.
You gotta share it with the whole class if you're gonna cook something in class, all right?
Cookies.
How about I do this one? A and B. Oh, the second one's even a little scarier. This one's a little bit easier. This is definitely one of those things where I would recommend, unless you're just really good at it, maybe redrawing the triangles so that you are clear on which side corresponds to which, right? And I mean, in this case, it's just two numbers, so it's actually kind of simple. Because you could just look at the smaller one, smaller to smaller and larger to larger. But this is what the triangles actually, if we draw them with the same orientation, this is what they look like. So what is the scale factor of figure A to B? So that's important as well. It's going to give you a number. If I had said the scale factor from B to A, that's a different number than the scale factor from A to B. So what would the scale factor of A to B be? Yes?
If you put 36 over 20,
36 over 20.
simplified, it would be 1.8.
1.8. Okay. Or you could leave it in fractional form.
Yeah.
Right. So if you left it in fractional form, you got 9 over 5, right? Which equals 1.8. All right. When I'm saying scale factor, this is more what I'm looking for because I want to know what that ratio is, right? It's like a 9 to 5 triangle. So don't simplify those to decimals. Keep it in that fractional form or write it like that. Will I count it wrong? Probably not. I'm too nice to you guys. I'm just too nice, you know? But yeah, I kind of prefer it like that. All right. 4, though, like I said, to me that's a little harder one because the way the figures are drawn there, not super hard, right? Again, just look at, you're trying to find the scale factor, so just find the smallest side on one figure and compare it to the smallest side on the other figure. So what would the scale factor be from going from figure B to figure A?
9 over 12.
9 over 12, right? So that's the smallest side in B. 12 is the smallest side in A. And so we can reduce that down to 3/4. That would be your scale factor. Okay? Also written as that. That would be acceptable as well. If you've ever bought a model, you know, like a car or jet or something like that, they'll have the scale factor to the real one on it, and it'll be written like that, right? What's so funny? You never bought a jet model? Okay, all right. Come on, man. It's not funny. Maybe if I said like a model, I don't know, SpongeBob SquarePants, maybe that would be funny. But yes.
It's funny because where I work, we do.
Oh, your hobby.
Yeah.
Wait a minute. Fate hobbies, right?
Yeah. So it's like 1/10 scale cars and planes, things like that.
Okay. It's not written. Is it written as a fraction or written like this?
Usually it's written as a ratio.
Yeah, like that, right? Yeah. All right. Any questions about scale factors? Sorry, I forgot to look. You guys speak up. Oh, was that a Dunkin'? There's a Dunkin' coffee in the bag. A Dunkin' iced coffee. That's my favorite. Medium, 2 mochas, and 2 creams. Just so you guys, in case you guys are wondering. Okay. 2 mochas, 2 creams, medium, iced coffee. Not a hint in any way. I'm just saying that's what it is. All right. So if we had the same thing in problem 5 and it says find the value of x, if we know that these triangles are similar, this is where it may be a little bit harder. You can't just look at the numbers and go smallest number to biggest number. Because we got to figure out, does the 20 correspond to the 25 or does the 20 correspond to the 4x minus 23 on that other one? But again, if you will redraw your triangles, and I'll just use the ones I've already drawn up here. And just based on the length of the side, recognize that this is the small side of the little triangle, and this is the small side of the bigger triangle. And then this is the side which is the longest side. And so that means that this has to be 4x minus 23 there. Then you'll be in good shape to write down your relationship between the two. So we would just say, you know, we could write it down in different orders, but we could say 25 over 20. This side to this side has got to equal the proportion between this side to this side. So 4x minus 23 over 2x plus 2. And then we could go ahead and cross multiply, or we could make our numbers a little bit simpler by saying, well, both of these are divisible by 5, so I could actually write this as 5 over 4, right? You could rewrite the whole thing like that. And then I could cross multiply. So 4 times 4x minus 23 equals 5 times 2x plus 2. And that's 16x minus 92 equals 10x plus 10. Does that look right to everybody? Looks right. So then, getting all my x's on one side, I've got 6x over here equals 102 on this side, and so dividing both sides by 6, I get x is equal to 17. Any questions about that problem? I feel like we all need a little bit of coffee. Yeah. Maybe we can have like some kind of like, we just hook up to an IV when we get in the room.
I need to go on a field trip.
Field trip to
Starbucks.
Starbucks. How many people would, if I say Starbucks or Dunkin', how many Starbucks people do I have? Starbucks, okay. Let me ask you this when I say Starbucks. Are we talking lattes or just straight coffee?
Lattes.
I've never had a Dunkin' coffee that I like.
Okay, well let me say this. If I'm choosing a latte, I'm going to go to Starbucks. If I'm choosing regular coffee, I'm going to go to Dunkin'.
Iced coffee's better at Dunkin'.
It is.
Lattes are better at Starbucks.
Amen, brother. That's right. He's exactly right. The lattes are weird tasting to me at Dunkin'.
I just get like a frosted coffee at Chick-fil-A.
Frosted coffee, Chick-fil-A, those are good
I'm
options.
not like a straight coffee guy, I like a little, just like a mocha frap or something, like just enough.
So I am curious though, you Starbucks people, raise your hand again if you're the Starbucks person. All right. So what do you have there?
Who do I have?
Yeah. What kind of drink? What's your drink of choice?
Iced mocha.
Okay, a latte. Good. All right. What's yours? That's my favorite too, by the way.
Venti iced latte with almond milk and 6 shots.
6 shots. It used to be like this in here. All right, but a latte again. Good choice. What was another? Who was another hand? David, what was yours?
The mocha cookie crumble. Well, I don't have
Mocha
any-
that's a frappuccino, right?
I guess so, yeah.
Okay.
I don't have any.
Is it or is it not, buddy? Come on,
I
commit.
don't know.
You don't know? Is it like icy taste? Yeah.
It's cold.
It's called a frappuccino. All right.
All right.
Go ahead. What was yours?
The iced chai tea with 2 to 4 shots of espresso.
See, that's what I was wondering. Do we have any of these chai tea people?
Chai tea people.
I am not that person. I'm not that person. But my wife loves that stuff. So yeah. I'm just not a huge. But you actually get espresso shots in it.
Yes, yeah, it's called the dirty chai. It's delicious.
Oh, the dirty chai. Okay, I've heard that. I didn't know that's what it meant. All right, Brittany.
Iced green peach tea.
Iced green peach tea. So that's really good at Starbucks. Interesting. I don't
Just
know
get
that I've
sweet
ever
tea.
had their green tea. All right. But peach iced tea tastes really good, so I can see that. And are you still at the Kroger over there? I was asking, did you use that Starbucks that was there? Did you
I
ever
did.
go there when you were there? Okay. Was there anybody else that was a Starbucks person? Yeah, okay. It just depends on the drink, right?
Exactly.
So I'm with you. Yeah, lattes at Starbucks, good. Coffee at Dunkin', good, right? But don't try to go the other way.
I've never had
I
coffee.
just have like, I don't, oh, have you ever had Arby's, are they called Jamocha shakes?
I have
The
had
Jamocha shakes are so
Arby's
good.
coffee.
I have had Jamocha shakes.
Oh, the
And
Jamocha shakes are so good.
the Jamocha shakes are great if they put enough of the Jamocha sauce in it. But
Yeah,
sometimes
you're
the
right,
Jamocha
you're
shakes just
right.
taste like a vanilla shake.
You're right, you're
I
right.
got
They need to
it.
put enough of it, but it's so good.
It is good. It's good. Hey,
It's so good. It's so good.
you prefer what? Wait. Come on here. This is serious, guys. This is serious, okay? We're talking coffee. If there's any time you need to be quiet, this is it. What were you saying, Abe?
I prefer local shops like Circa, Leaf and Beans, Sonoya Coffee. Those
Yes.
Has anybody tried Rooted?
Which one?
Rooted?
Yes.
So Rooted is like right down the road where the gym is in, it's like just before, it's on the left just before you get to where the big 74-54 intersection is. So you know the big gym that's over there? There's a Rooted coffee that's fairly new. They're good too. I've got some friends that work there, so I'll put a plug in for Rooted if you want another local shop to check out. But yeah, Circa and Cacao's got good coffee if you ever go there for coffee. Theirs is good. Yep. Anything else? Any other coffee enlightening information that you guys want to share? What?
Yeah.
What'd you say?
Yes,
Oh, it's bad? Oh, no. Poor guy. Poor guy.
Coffee's
Yeah, into the dust of shame.
I usually have
Yeah,
coffee when
that's
I'm
good
really,
shake.
really tired. So I just have coffee. So, like at horse shows, when I'm at the horse show, 5, 6 in the morning until like 10 o'clock at night, we have really long days. I usually
I feel like we've got a wild
I'll usually have a little coffee to get me going. Just enough, and just I think I only had Cooper once, and it was by accident. I accidentally no, not really. Like so, if you so I had iced soda and like a year or so maybe, like straight soda. Sometimes I'll mix like water with like the medicine stuff, like a little bit. It's really good, really good. It's really good. But I haven't had straight soda in like a couple of years. But if you go acid, it tastes like syrup. I have a main soda.
All right, guys. All right. Back. My tactic worked. You guys are definitely awake now. But let's do another one of the problems and let's see if we can solve this one. This is number 9 on your worksheet. And so it tells us to start with, it tells us that NKF, which is the big triangle here, is similar to this little triangle LZF. And then this is the important point. Find NF. Right? Like I said, with the last test, some of you guys did a great job solving for X, but we weren't asking for X. We were asking for some other value. So we do need to solve for X in order to find NF. Hey, that's a rapper, isn't it?
Yeah.
It is? I don't listen to
Is he the one that does church clap?
No.
Who does church clap? No, he's not that kind of rapper. Who does church clap? Anybody know that song? Yeah?
Yes.
Who is that? Who is church clap?
I don't know.
That's KB.
KB. That's it, KB. Okay.
Why are these guys named after
I
line segments?
love church clap, so we do church clap like all the time.
All right. So I like church clap. So let's see if we can figure this out. Right? We need to set up some sort of relationship between these two similar triangles. Okay? And what would that relationship be? Well, first, I'm going to just go ahead and draw 2 to make sure that we can all follow what the lengths of the sides are that we know. Okay? So for this little triangle, clearly I have x plus 3 and 4. I know those lengths right there, right? So if I'm going to be able to draw a ratio, I'm going to have to know the same sides on this triangle as well. So do I know the length of those sides? What's the length of this side?
X plus 3.
It's x plus 3, right? So we know the length of that side on the big triangle. Let's go ahead and label our L, C, F. What about the length of this side? Do I know that one?
18x? Or 18 plus x.
18 plus x. So just make sure everybody understands, all she did was say 15 plus x plus 3 will give me the length of that side. So often in these types of problems, I may not give you the length of the side explicitly that you need, but you'll be able to either add or subtract to figure that out, right? So since we know the length of this is 15, and we know the length of this is x plus 3, then the length of the entire thing is going to be those two added together, right? So that's going to equal 18 plus x, okay? So now I have values where I can set up a ratio. Did I draw that right? Yeah. And figure out, and finally figure out what NF is. So what would our ratio be? X plus 3 over what?
Over 4.
Over 4 is equal to what? It goes on top.
18 plus x.
18 plus x. I could have done that as x plus 18. I probably should have. That's what we got that in the other one. So I'll write it as x plus 18 over
X plus 3.
x plus 3. So this is what it's important that everybody know, right? This x plus 3 came from here. X plus 3 over 4 is equal to 18x, or x plus 18 over x plus 3 here, and that x plus 3 came from here. So this over this is equal to this over this, right? And so now, ooh, this is another quadratic. I can't believe I picked another, but this one's interesting because there actually ends up being only one answer. This is a simpler quadratic, so let's see if we can do it. X plus 3 times x plus 3 equals 4x plus 18. When we do the math for this, we have x squared plus 6x plus 9, right? That's just using first outer inner last as I multiply through and then add my terms. This is going to be 4x plus 72. Is that right? Yes?
Wouldn't that be an x squared, the first? X
Yes, it
squared
should.
plus-
Thank you.
Okay.
I think I said it, I just didn't write it.
Oh, yeah.
So 4x plus 72, so we'll move all of our terms over to one side and set it equal to 0, so that gives us x squared plus 2x, what's 9 minus 72 is negative 63, equals 0, I think. Yes. And so this one's definitely easier. We're going to factor this guy. And one's going to be x minus, the other one's going to be x plus, because we have to end up with a negative number when we multiply those last two terms. So what factors of 63, when I take the difference of them, will give me 2? 7 and 9, right? And I want to end up with a positive 2, so the 9 is going to go in front of the, after the positive, and the 7 after the plus sign, and the 7 is going to go after the minus sign. So those factors there will give us this quadratic equation. And so if we, setting each equal to 0, remember what I'm doing here is x minus 7 equals 0, and x plus 9 equals 0. And so that means x equals 7, and x equals negative 9. So I get two values again for that. But like I said, for this particular problem, there's actually only one answer. Why is that? This problem asked for what?
NF.
NF. And we know that NF is equal to x plus 18, right? If I plug in the 7 for x plus 18, I get that NF is equal to 25, right? If I plug in the 9 for x plus 18, I get a negative 9. Oh, wait a minute. I get 9 for that. But can 9 be right for NF? I thought one of them was going to be negative and one of them was going to be positive, but it's not.
No, wait. Not.
Can NF be 9? Yes.
No, because if you plug it into the x on the other side, the negative 9 plus 3 would equal a negative, so, right?
Well, I was just looking at the fact that NF, this whole thing here clearly can't be 9
Right.
because we know part
Yeah.
of it's 15, right? So it's got to be some number that's bigger than
So
15. So sometimes whenever you get two answers like that, one of the numbers can't be right. Even though it worked out with the quadratic equation, it can't be right when you plug it in because of the physical limitations of the object that you're working with, right? So if if one of these numbers had given us a negative number, clearly it couldn't have been that value of x because we can't have a negative distance on a triangle. But in this case here, we also know that it's got to be greater than 15 when you add all that together. So 25 is the only answer that makes sense, right? Okay, well that got us through just a few of the problems. We worked, excuse me, we worked problems near the end of it. We did those from the quiz today, so we kind of have already worked problems similar to that type. But the review, the study sheet is going to give you an opportunity to use like variables and all some of those problems and solve with a variable. Yes?
Are confusing problems like this going to be on the test?
I probably won't give you any quadratic equations. I just don't. Like I said, if I do, it'll be by accident. Sometimes I'm using a program for generating the problems, and sometimes it generates a problem that I don't realize is going to end up with a quadratic. So I'm not going to intentionally give you this. And we'll cross that bridge if I get you one, and you guys will all go, Mr. Walker, you said you were going to give us a quadratic equation. And I'll be like, you're right. We'll just drop that problem. Right?
So that's what we'll.
So yeah, it won't be. I'm not intending to give you anything that's a quadratic. However, a problem like this, you need to understand how it works, right? It's just, if I give you one like this, I'll try to do it to where it won't work out with the quadratic equation in the end, okay? All right, any questions? I got students already standing outside my door. Is it time already? We got 4 more minutes, right? Before, well, if I give you 5 minutes to get to your next class, if you got a next class. Is there any, if you look over the paper, is there anything you want me to do quickly? Any other of the other problems? Take a stab at the proofs. Like I said, I will send you the solutions for that, and you can see if you got it right.
Read the proofs on the test.
If I give you one, it'll be a simple one that, like I said, you'll just have to fill in the blank for if you are.
Okay.
Okay?
Do you need to look at our homework?
Hey, that's a good idea. Do you guys want credit for your homework? That wouldn't be bad. That's an easy 100. So, sorry, you're putting your stuff away. Now, let me see your homework real quick.
Well, if you're gonna do it, fight, you're getting out of it this time.
I had my homework for 9.
Ha.
I said, I forgot to write it down, but
Okay. Did you do all of that? What I gave you guys last time?
Yes.
Okay. All right. So you can email me that. Okay. Excellent. Excellent. Good. Good. Sorry, I know you guys are packing up.
The note. The note. Like, I was like,
Well, what we did in class.
Excellent.
oh yeah, you're right. I knew there was one of them like that, but I wasn't sure. Yeah, okay. Probably, it would be some hero that, I mean, I could also look at that. That's not right.
All right, good. Okay, that's good. All right.
like find and they have to be equal to the number with the 1 at. So like in 64